Then we need another electron to make a bond. So that comes from the pi bond. Do you see my arrows?
Yeah. Mm-hmm.
And then what about the other electron in that pi bond? So there are
Oh,
two.
it lost.
No, it's not lost. What do you mean lost?
Well, gone,
Goes
broken.
to that carbon. It goes to this carbon.
It's broken, right?
Yes, the bond breaks. One electron goes here, makes the pi bond. The other electron goes right there.
Okay. Okay.
Does that make sense?
Yeah. Mm-hmm.
So we, excuse me. So sorry. So similarly, if we are writing the curved arrows for the next one, uh, so this electron goes here, single electron, one electron. And one electron from that bond goes there, makes a bond, becomes a double bond. And the other electron goes to this carbon atom. So you have that radical now.
Okay.
So it's all about counting your electrons and see how the electrons are moving. But you do have to make sure it's single electrons.
Yeah. And the reason we're going left is because it's allylic. It's going to the allylic side or to the bond.
Oh, yes, absolutely. I mean, let's say, for example, excuse me, I'm so sorry about my throat. I don't know what's going on this morning. Let's say, for example, if this electron were going here, then I would need to break a sigma bond. We can't break sigma bonds. If you remember from first quarter,
Yeah.
resonance never breaks sigma bonds.
Mm-hmm.
Resonance never breaks
Sigma
bonds.
bonds. Okay.
It's only about pi electrons or electrons in the unhybridized p orbitals, right? So can't break sigma bonds.
So it can go right. Yes, it can. But if it's got, if it's going to break a bond, if there's a bond, whatever. Okay.
Not sure what that means, what you just said, but can it go right or left depends on where the pi electrons are.
Yeah. I guess that's what I meant.
Yeah, exactly.
Okay. So
Not break a sigma bond.
so so for the next one, 10.6, the question is.
Let me delete this stuff. 10.6 you said. Okay.
The major product of the reaction of methane.
What section are you? What section?
10.6, 10.4. At the end of 10 point, before 10.105.
Okay, good. So which question is it? 10 point what?
6.
6, okay. Anyways, you go ahead and read the question. Oh yes, found it.
Yep.
Found it. Okay. The major product of the reaction, that one?
Yeah.
Yeah, so what's the question?
Okay, so here we have NVS, NBS, and we just take the bromide from there, right?
Yes.
And why do we take just that bromide radical and then
NBS, as I was saying yesterday, oh shoot, there it is. NBS, which is this structure.
yeah, and I don't see the end but I guess that's not matter.
What do you mean? Hold on, I'm not. Let me finish what I'm
Okay.
saying. NBS is this. But what it does is, when there is heat or light, it breaks homolytically and creates a Br radical. So it's this Br radical from NBS, which is what they are showing.
Oh, okay. So that's all we take from that NBS.
Exactly. It's just the bromine atom, the bromine atom that NBS creates.
Okay.
The one that does the free radical reaction.
Okay, now let's see the reason we put it in that.
Well, if it's a radical reaction. If it's a radical reaction, which means this guy, sorry, again, pen, come on, my pen. Which means, again, you got to think of, okay, what will be the most stable radical this is going to create? The most stable radical that this is going to create is that, right?
Because it's allylic.
Exactly, right, exactly.
And it's a secondary, well, they're all secondary, but that's secondary allylic.
And allylic, exactly.
Well, could it be also, well, it's the same thing if you put it on the other side, of course.
Right.
Oh, duh, yeah, okay.
Symmetric.
Got it.
But this can undergo resonance because it's allylic. It can
Yeah.
undergo resonance. So if it undergoes resonance, what's the resonance structure? The resonance structure is this.
Now the HBr,
That's the byproduct. In all of these reactions, there is HX is the byproduct.
where does it come from though, the H?
Have you written the mechanism?
Have I? No, I haven't.
So when you write the mechanism in the propagation stage, step number 1,
Okay.
I'm using just RH for now because, right, in step number 1, the radical comes and takes a in step number 1 of the propagation stage, the halogen radical takes a hydrogen atom, creates an organic radical, doesn't it?
Oops, sorry. Yeah.
That's okay.
Mm-hmm.
That's where it's created. And of course, step number 2, that radical reacts with another equivalent of the Br2 to, do you remember writing this mechanism?
Yes.
Yeah, so wasn't HBr created, right, in
Okay.
step number 1?
Okay, so for these, I should have written the mechanism too. I didn't, yeah.
Well, not just for these. This is the same mechanism for all of these reactions. So if you know the mechanism, yep, that's happening in first step, this is happening in second step, blah, blah, blah. You will see that, okay, there is an HX, there's an HCr or HCl created whenever there is a free radical halogenation.
Okay,
That's the byproduct, the side product,
okay,
right?
okay, and whoops, I guess we can.
So Mar, I do have that student now who's joined the Zoom, who
Okay.
has an appointment with me.
Okay,
So you have to take them.
yeah.
If they have a
I'll see you tomorrow.
Sure. Or what I was going to say also is, excuse me, if you want to wait, because I don't know how much time they are going to take. They might just take 10 minutes. They might take.
Oh, okay, I'll wait. In the meantime, I'll try to work with this one, and then, yeah.
So I have time till 9:50. So if
I know.
you leave, then you and I can continue.
Yeah, I understand. And if you don't come back at 9:50, then that's fine.
Yeah. So yeah. Thank you.
Just, okay.
Otherwise, I'll see you tomorrow then. Same
Yes.
Zoom. Use the same Zoom.
Thank you.
Yeah.
Have a good one.
You too, Mar.
How do I leave? Let me see.
Mar, you need to stop sharing your screen first.
Oh, okay.
Hi, Michaela. Give me just a minute.
Jeez. I don't know how to stop it. It says share. Huh?
Somewhere on the top.
Oh, there. I see it. Stop share.
There you go.
And then do I just
I can do it too. There we go.
do I just cancel audio? Or how do I leave?
Oh, if you want to leave, there should be a button on the bottom square that says end or leave meeting.
I want it to be on standby, so
Okay, then just mute yourself.
okay, we'll do that.
And we can, yeah, thank you. Hi, Michaela. How may I help you today?